Welcome back to Space Nuts. I'm your host for this episode, Heidi Campo, and joining us today is Professor Fred Watson.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Fred, how are you doing today?
Very well, thank you. It's a bit soggy in Sydney. I understand it's been a bit soggy in Houston as well.
It absolutely
with rainy weather.
has. We've been getting rain like crazy, but I'll tell you what, this time of year here in Space City is so beautiful because we have these trees. I can't remember what they're called, but they get the most beautiful flowers on them. So we have all these floral, fragrant trees everywhere. So it's amazing. If you guys could come visit Space Center, come check out Johnson Space Center, do the tours and see our beautiful trees, this is a great time of year to visit.
I think it was this time of year when we actually did that as well. No, a little bit earlier. It was so it was last year, but it was a little bit earlier. I think it was about April. So we probably didn't see the best of the trees, but we certainly saw the Space Center and your museum. Houston's got the most fabulous science museum. Absolutely brilliant.
We do pretty good.
So,
I'm sure you probably met some of our local mosquitoes around that time of year as well.
Maybe, yes.
With it being in a swamp in the bayou, we certainly get a lot of mosquitoes. But with our stories today, there's no mosquitoes out there in space, which is, I think, one of the attractive properties. We have some incredible stories today talking about some of the new images coming in from a revolutionary telescope. We're going to be talking a little bit about what's going on the International Space Station. And then the last story is the one that I hope you guys stick around for, because this is something I'm a little bit excited to talk to Fred about. It's these mysterious ridges on Mars. And I'm so excited to hear about this, Fred. So let's just kind of jump in with this telescope. I'm looking at these images, and I say this with almost everything, so you guys probably think I'm just lying at this point, but it's so beautiful. I just am I'm never not in awe of the images I see from these telescopes.
Yeah, and I guess what revolutionized the images that we see from modern day telescopes was the fact that we've got color in them, which certainly when I was a young astronomer back in the 1850s or whenever it was, there wasn't. Everything was black and white. There was no color because the color emulsions weren't sensitive enough. And then my colleague David Malin came along at the Anglo-Australian Telescope, figured out how to do 3-color imagery and put it all together to give us true color images. And that's now done electronically with charge coupled devices and the wonderful software that people have access to turn these images into these beautiful, artistically graceful images that we see. And that's my segue, I guess, into the story, because the camera is one of the key components. This is a brand new telescope, and the images that you're talking about, Heidi, which include nebulae and galaxies and all the usual stuff that we're used to seeing, but this time in such detail and with such imposing colors is perhaps the wrong way to say it, but you really feel as though you're actually in the action there with the nebulae and the galaxies. The secret of that is, first of all, the telescope itself is an 8.4 meter diameter telescope. That's the biggest scale of telescopes that we have access to at the moment, the 8-meter class telescopes. It's on a mountaintop called Cerro Pachon in northern Chile. I've not actually visited the mountain, but I've seen it from the other side of the valley. There are several telescopes up there. But what makes it special is for two things: the wide angle of view that the telescope can see. So instead of just homing in on a tiny, fine little bit of detail in the sky, it does that, but it does it with a very wide angle of view. So you see detail everywhere. And that is partly because of the design of the telescope, but also, and the segue I was getting to, it's taken me a while, the camera, which is a 3,200 megapixel or 3.2 gigapixel camera. I think it's the biggest camera of its kind in the world. It's the size of a small car, and it sits at the focus of this telescope, recording these breathtaking wide-angle images. The instrument we're talking about, this has been in construction for best part of 30 years. We've been talking about this telescope in the world of astronomy. And at first it was called the LSST, which was the Large Synoptic Survey Telescope. It's now called, I think I'm right in saying it's the Charles Simonyi Telescope, because I think Charles Simonyi, a very well-known name in space philanthropy, I think I can put it that way. I think he was the first paying customer on the International Space Station back in the early 2000s. Wow. So a wealthy person, but somebody who can put that wealth to good use in a scientific sense. But the observatory itself, where this telescope is named after one of my favorite characters in the whole of astronomy, Vera C. Rubin, whose name might be familiar to you. She was a compatriot of yours. I can't remember where she grew up, actually. Should have checked that, shouldn't I? Vera, she was one of the pioneering astronomers of her time. She died in 2016, Christmas Day, if I remember rightly. She passed away. She was a good age, wonderful, wonderful person, very great champion for women in science, and somebody who put her stamp not just on the science itself, but on the capabilities for astronomers. She basically was the person who put dark matter not so much on the map, but raised awareness that this was a real issue, that there was something out there that weighed much more than the normal matter that we can see, that was basically something we needed to explain, dark matter. She wrote a series of really influential papers in the late 1970s.
That's amazing.
So she was an extraordinary woman. So it's fabulous that this telescope the observatory carries her name. So the Vera C. Rubin Observatory.
So, Fred, I've kind of got a little bit of a detour question for you. So get your thinking cap on. When we talk about these telescopes, you said a couple things that stood out to me. One about this woman who sounded like just an incredible human being who really left her mark on the world. But the one thing that really stuck out to me is you said this telescope took 30 years to build. And so I know a lot of our listeners are people who are still maybe in school or considering a field in these sciences, or they're early career professionals. Can you talk a little bit about what it's like to dedicate yourself to a project that's going to take 30 years? It's your life's work. How do you choose at maybe 25 years old to say, this is something I'm passionate about and I'm going to work on this for 30 years? Like, how do people do that?
Well, they do. No, it's a really good question. So with the telescope, it was the brainchild of a few people. And I haven't really got to the main issue that this telescope will do. I'll keep talking about your question. But the main point about this telescope is that it can survey the entire southern sky every 3 nights. So it's got the capability to record the whole sky in detail every 3 nights. So what it's really looking for are things that change. And that includes things changing their position, which is asteroids. In the first 10 hours of observing, it discovered 2,100 asteroids, which is, it's going to really start changing our view of the Earth's locality in space. And also things that go bump in the night, the supernova explosions, things of that sort. This will be the telescope for picking that up. So yes, 30 years ago, people were thinking what we need is something that can tell us about an aspect of the universe, that had never really been thought about before. And that is the way things come and go. Because we, in traditional astronomy, things change in the solar system. The planets are going around on short timescales. But it's only recently been realized that there are things happening everywhere that happen on short timescales, like black hole mergers, like neutron star collisions, like supernova explosions, stars that have got to the ends of their lives and have basically blown themselves to pieces. So that was the vision for that was seen by a few scientists yet 30 years ago. And they began working towards raising the funding, raising the technology. The technology just didn't exist back then to build a telescope of this kind, and eventually to get it made. So some of those people right at the outset were quite senior people with the vision to see what might occur. And they are probably, some of them are no longer with us, but they would have had students and postdoctoral fellows working with them. And they're the people in exactly the way that you've just described. They have seen what the potential is for a project like this. And they've put their noses to the grindstone and stuck in there to eventually see the moment that we're seeing now, the start of this telescope, the first light in images that we're seeing.
Wow.
So for those people, this must feel like a triumph for those postdocs and PhD students who were working on that. Just another example, though, of this, and we're spending a bit longer than we probably should on this story, but the same is true in space missions. And in fact, even more so, because there's no quick fix if you're doing a science space mission. And the one example that, excuse me, I've got an itch on my nose. The one example that comes to mind is somebody who Marnie and I know quite well, Linda Spilker. She was the project scientist for the Cassini mission, NASA's mission in orbit around Saturn from 2004 to 2017? It was in orbit around Saturn. And she basically dedicated her life to that project. She started off working on Voyager, in fact, at the beginning of her career, which was one of the pioneering ones, but then switched to a mission to go to Saturn and worked on that for probably more than 20 years, culminating in being the mission scientist. I think that was one of the best space missions that's ever happened, because we learned so much. But she's now working on the possibility of sending spacecraft to some of Saturn's moons, like Enceladus, where we know there's an ocean of water underneath the icy surface. So in some ways, people start off, with one project, but it germinates into something else that does become their life's work. That's certainly what happened with Linda. So, yes, for the people who were involved right at the outset of the Vera C. Rubin Observatory, or the LSST as we used to call it, this must be a moment to savor. And, I'm sure there are people out there who are in exactly the situation that you've described.
That is such a cool part of these sciences, is the things that we do, we may never see the fruits of those labors in our lifetime. And so the people who really commit to the true visionaries, not just the people who want to do it for a title or, getting the Netflix documentary, the people who really want to change the future, is usually a future they may never live to see. And they know that, but they commit to dedicating their life to this work. And that's just amazing and selfless to me. And, there's a lot to be said about the leaps that we make with the people who think that way. But we also need the people who are going to go out there and then, do the work, the people who are going to make that vision, actualize it. And those are the astronauts who are out there living on the space station right now. These are the people who are building on the sciences that we've been working on since Galileo. This is stuff humanity's been working on for a long time.
0G, and I feel fine. Space nuts.
Yeah.
So with that being said, I think that's a good segue into talking about what's going on the space station right now.
And it's a busy time. I was struck when I looked, I try and keep an eye on what's going on the space station. But we've got, it's getting a bit crowded up there, I have to say. So at the moment, we have 11 astronauts living on the space station. And I was interested to read that they've all sort of divvied up all the sleep stations that there are, and the various people are sleeping in effectively cupboards and workrooms and things of that sort, so that they all have their sleep stations. So what's caused this? There are currently 7 astronauts, NASA astronauts, who are the working sort of standard astronauts on the space station. They are a member of what's called Expedition 73, those 7 astronauts, but they've been joined by 4 privately funded astronauts on a mission called the AX4 mission. It's Axiom Space that is doing that with specific requirements for experiments. I think Axiom have got something like, they've got 2 weeks on the space station, and I think they've got, I don't know, 5 dozen or something experiments that they've got to do, some of which are very much along the lines of your own interests, Heidi, because it's all about human, the way humans interact with space. I was really interested to read that one of the experiments was something called the thigh cuff. And a thigh cuff is a tight cuff on your thigh, obviously, and it's all about trying to change the way the fluids move in your body, because in weightlessness, the fluids in your body do unusual things, and they tend to pool inside your head, which is not a good thing. And so basically, that's one of the experiments that's been done. I don't know whether you're familiar with the use of thigh cuffs.
Yeah, so I was reading this right now, and at the risk of sounding foolish, in case anyone out there is listening who knows a lot more about this than me, I was reading this article to try and see if they specify if this thigh cuff is BFR technology or if it's separate, because I don't know everything, but I think, I'm saying think in italicized right now, I think when they're talking about a thigh cuff, what they're talking about is what they call BFR technology, which stands for blood flow restriction technology. That is a training and exercise technique that's used here on Earth. It's actually become quite popular with bodybuilders because they've realized that they can get greater muscular hypertrophy benefits when training that way. And if you guys don't know what muscular hypertrophy means, that's increasing the muscle size. So in space, one of our big problems is muscle atrophy. We're losing muscles, we're losing bone density. So when we train with blood flow restriction, it helps sort of expedite, there's no shortcuts, but it does enhance the effects of exercise. And the more interesting thing, I don't know if it's more interesting, but an additional benefit is they're actually using it to help mitigate the effects of SANS right now as well.
The effect of, sorry, I missed the word you said there.
SANS,
okay.
SANS. I'm surprised you haven't heard about that one. I get to teach you something. SANS is a neuroocular syndrome, which affects vision of astronauts in space. Yeah. So their vision
Didn't know
changes.
it was called that.
Yeah. It has its own acronym, just like everything else up there.
So, that's quite a serious one, because that's one of the deleterious effects that spaceflight has that does not recover when you get back to normal gravity.
Sometimes it does.
Okay.
So sometimes it improves, sometimes it doesn't improve, sometimes they make a little bit of progress. And there have been cases, believe it or not, where crew members have gone up needing prescription glasses and have had to wear prescription glasses their whole life. Yeah. And they go up there and they come back and their prescription is fixed. And they've joked, the joke was made when I was at this presentation. They're like, that was the most expensive eye corrective surgery ever.
But that's fantastic. Look, I had not heard that. So if you want to fix your eye problems, go into space
or make them worse. It's a roll of the dice.
Yeah, might wait. Yes, it's a bit of a toss-up as to which way it goes. So just celebrating the fact that we do have such a busy space station at the moment. The leader of Expedition 70, I beg your pardon, the leader of the Axiom 4 crew is, and this is the privately funded one, is actually Peggy Whitson, who's a big name in astronaut circles. Mm-hmm. I think she holds one of the records for, the record for the most time in space by an American and worldwide by a woman. So she is very much a veteran of spaceflight. And what, you didn't really imagine a better leader for a flight crew than somebody like Peggy. And the other thing I liked is that not only is the space station getting pretty full, but all the parking spaces are getting used up as well, because there are 3 docked crew spacecraft at the moment, and there are 2 docked cargo spacecraft at the moment as well. And, there's not that many docking ports on the International Space Station, so I think they're running out of space up there. It's great to see it being so busy at the moment, given that we're probably going to lose it in 5 years' time. So make the most of it.
Yeah, it'll be it's amazing what's going on up there. It really is. And I just forgot to also mention, speaking of busy, I think today's International Asteroid Day.
Okay.
I think I saw that on LinkedIn.
Yeah, it's so that celebrates, I think if I remember rightly, International Asteroid Day is the day of the Tunguska meteorite or asteroid impact, which happened in Siberia in 1908.
Is that the one that got the dinosaurs?
No, that's right. No, that was 66 million years ago. This was only a century ago. Let's just do...
We're just trying to keep our listeners on their feet.
Yeah, absolutely. Asteroid Day 2025. Yes, it's yesterday our time. It's the 30th of June. You're absolutely right. And it's that's the celebration that it's the date of the same day as the 1908 Tunguska event. So,
well, happy Asteroid Day, Fred.
Yeah, and you too. I did my master's. Sorry,
go ahead. You go.
No, I was just going to say I did my master's degree on researching asteroid orbits with these newfangled things called computers. And in those days, it was very unfashionable to be interested in asteroids. But it's not now, because we're all interested in asteroids. Who knows what they might do.
Roger, you're loud and clear here also.
Space nuts.
Yeah, speaking of asteroids, do they have anything to do with these weird landscapes on Mars? I was scrolling on social media a couple days ago, and I came across these images of these weird ridges and craters on Mars, and it's weird. The shadows some of the pictures I was looking at, the shadows almost looked like trees. And for a second, I had this weird, and I was fantasizing Mars terraformed, but it not looking like Earth, it looking like an alien Earth, and I was like, wow, that'd be so weird. But yeah, what is going on with this landscape?
It's a surprise actually to everybody, including you and me. So and this comes from Curiosity, the rover that's been working hard on the surface of Mars for what was it, 2012 when Curiosity landed? I think it was a long time ago. So Curiosity is at a place called Gale
2014.
2014, okay. Gale Crater has a mountain on it called Mount Sharp, and that's what the spacecraft was designed to explore, which is done very well. But we've got, in Gale Crater, we've now got this new form of, it's a landform that has never been seen before. And they're calling it the boxwork lattice landform. And that sort of gives you an idea of what it might look like. Some of these, I'm actually thinking, perhaps it's just the way my mind works, but I'm thinking of those inserts that sometimes go in a box of a dozen bottles of wine, because they have cardboard inserts in them that are sort of like this lattice shape. And I think that's the shape of these ridges that have been found. They're not very deep. They're only a few inches high, but they're ridges in an absolute pattern. Very boxy looking pattern, and they haven't been seen before. And so that is exciting the planetary scientists who are looking at the results coming from Curiosity. And so, of course, the first thing you have to do is work out what you think might have caused them. And the current theory is that when Mars was drying out, and this is probably 3.8 billion years ago, because we know it was warm and wet before that, but when it was drying out, there was probably a very dry surface, but with groundwater that was underneath the surface. And that groundwater would have been rich in minerals. And basically, what it did was came up through cracks in the bedrock. So the bedrock itself has had to crack and let the groundwater up through the cracks. And what we then see is the groundwater disappears, it leaves the minerals behind. The minerals are harder than the bedrock itself. And so as the bedrock wears away with the effect of dust and wind over the last 3.8 billion years, you're left with this almost a structure that looks a bit like a curb, on a roadway.
Yeah.
But it's shaped in a boxy pattern. So yes, quite remarkable that we're seeing new landforms that have not been identified before. And of course, all of this helps by telling us about the history of Mars and the confirming, perhaps yet again, that Mars once had a lot more water than it does now.
I'm also looking at some searches, and the conspiracy theorists are going crazy with it's remnants of a city.
Okay. Oh, yes. I never thought of that. Yeah, remnants of the city. Well, that's right. We of course, pareidolia. That's do you know about pareidolia? It's a lovely word. I'm sure you've come across it. Yeah, it's when you see familiar things in objects that have nothing to do with them. So when you see figures in clouds, or when you see rocks that are shaped like like a truck tire or a spoon or whatever, it's our inbuilt ability to recognize shapes in things that are quite unrelated. And of course, the classic one on Mars was the face on Mars from the Viking orbiters back in 1976. This clearly a human face on Mars, and it gained so much. It was a giant. It was a landform actually, but it gained so much publicity that NASA actually changed the orbit of their next spacecraft so that it would fly over this area and take images. And of course, we could see it was just a crumbling mountaintop, not a face at all. But,
it inspired that weird movie, Mission to Mars. Did you see that one?
May have done.
It was
Can't
goofy.
remember.
It was goofy. It scared me when I was a little kid. There's like a tornado and an alien, and
probably scared me too.
Yeah, it's the humans' ability for recognition. I think about AI and how AI is getting really good at recognizing things, but the human brain's ability to make these recognitions, I still think it's unmatched. I don't know. The technology is probably catching up, but it really is fascinating, like recognizing emotion and very, very subtle changes on the human face. Have you ever heard of the term the uncanny valley?
Oh no, I haven't. No.
It's a term used a lot in like film design, like in like scary movies, but it's also in like art and anthropology. But long story short, the uncanny valley, if you're looking at a cartoon face of Mickey Mouse, where it's like, okay, it's kind of like human, there's an eyes, nose, and mouth. Mickey Mouse's face is not scary at all. It's just cute and cartoony. But the more realistic it gets, but it's still cartoonish, there's a point where it starts becoming scary. And that's where a lot of like people will use the example of the movie The Polar Express, where the CGI was really good, very human-like, but there was like a blank stare. And the emotions weren't quite right. So they call it the uncanny valley because it's a point where we see something that's almost human, but it's not quite human, and we don't like it. It makes us feel unsettled.
Yeah.
And it's crazy that humans have that built-in unsettledness with something that's almost human, but not human.
No, that's very telling about something deep in our, in our psyche that probably goes back to ancient times in our evolutionary makeup.
There's lots and lots of theories. Let us know what you guys think. If you guys have any thoughts or theories on the uncanny valley and how that relates to our pattern recognition of the man on the moon or the face on Mars, or how I saw these images of these rocks on Mars and I thought of trees right away.
Obviously, some others thought about cities as well.
Yeah. What did you see when you looked at this, Fred?
I saw pretty well what I was being told to look for. Ridges. Oh, it's ridges. Yeah.
Good analytical mind.
Yeah. Well, that's not perhaps it's not a good analytical mind. I just take it for granted. Yeah, it's a good point. I did actually, there's quite a nice, on the one of the websites, and I'm sure it's well available, there's a nice 360-degree panorama from Curiosity that you can scan around, and you can actually see these ridges from Curiosity's viewpoint. So it's worth a look. I think that's come from JPL, which of course is the organization that is operating the spacecraft.
That's fantastic. Fred, this has been so much fun today. Thank you for joining me and bringing some sunshine to our rainy day, keeping us all curious.
It's always a pleasure, Heidi. And yeah, we've got rain coming here too, so I might need a bit of your sunshine when the sky's clear in Houston.
All right. Well, hopefully the rest of you are all staying warm and dry. And we thank you so much for joining us. And this has been another fun, exciting, enlightening episode of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.